Hello, let me begin with a question. What concept in maths links amount of paper you would require to gift wrap a gift, the amount of paint you would require to paint the external walls of your house, the amount of icing you would require to cover all the faces of your cake, or the amount of label which you require to cover a, a part of your tinned food? Well, the concept which links all of these is the surface area of 3D shapes. So welcome to the session on surface area of 3D shapes. What are we going to learn in this session? First, we'll try and understand what do we understand by surface area of any 3D shape. Then we'll understand what are the components of surface area. Okay, which are the components which make up for the surface area of any 3D shape. And finally, we'll devise a formula to calculate surface area of any prism. Let's get started then. First, what do we understand by surface area of 3D shape? Simple, it's the total area of all the external surfaces of a 3D shape. So if you look at all the external surfaces of any 3D shape, if you add up all the areas, okay, that's what is the surface area. For example, if you look at this hexagonal based prism, what are the external walls or external faces of these 3D shapes? Well, as you can see, it has two hexagonal bases, one on top and one at the bottom. Then in this specific case, because it's a hexagonal prism, it has six rectangular walls, as you can see, right? We're just opening up the walls. As you can see, there are six of them which are there. So the surface area of this particular prism would be nothing but area of the two bases added to area of all the six walls, right? That's what is surface area. It's as simple as that. So surface area is basically area of the surface of a 3D shape. And when you talk about surface, it is always the external surface of a 3D shape. Well, let's take an example. Okay, how about surface area of this particular cube? If you look at it in a cube, all the dimensions are the same. And in this case, it is 4 centimeters. And each face of a cube is a square. So what will be the area of each of that face of the cube? It's a square with side 4 centimeter. So the area of each of those faces will be 4 squared, which is 16 centimeters squared. How many faces does a cube have? Okay, just for your benefit, we have put the net of a cube alongside. As you can see, there are 6 faces in a cube. Each of these faces has an area of 16 centimeters squared. So the total surface area of this cube will be 6 times 16, which is 96 centimeters squared. Right. So if I were to generalize this formula, instead of 4 centimeters, let me just change the side to S centimeters. So what will be the area of each face of the cube? It's a square with side S centimeters. So the area would be S squared. And how many square faces does a cube have? There are 6 square faces, as you can see from the net on the right, each of them having an area of S squared. So 6 times S squared, which is 6S squared, is the surface area of any cube. 6 times side squared. So you square the side and multiply it by 6. Remember that formula. That's how you calculate surface area of a cube. Well, how about surface area of a cuboid? So here we have a cuboid with width 4 centimeters, length 6 centimeters, and height 5 centimeters. How do we find surface area of that cuboid? So let's try and find out. As you can know, cuboids have rectangular walls. So we have to just find area of each of those rectangles, add them up to get the surface area. So which are the rectangles that this particular cuboid is made up of? If you look at the front and the back side, there are two rectangles, each having a dimension of 4 centimeters by 5 centimeters. Remember, the width of the original cuboid was 4 centimeters and the height was 5 centimeters. So each of those rectangles will have dimensions 4 times 5. And hence the area would be 20 centimeters squared. Each of them will have area of 20 centimeters squared. How about the front and the back faces? Again, rectangles. The dimension in this case would be 6 centimeters in length and 5 centimeters in width. So the area would be 6 times 5, which is 30 centimeters squared. And finally, we have two rectangular faces on top and bottom. What's the dimension of each of those faces? It is 6 times 4, as you can see, right? Base of that cuboid is 6 centimeters long and 4 centimeters wide. So 6 times 4. So each of those rectangles would be 24 centimeters squared area. Now we add up all these areas, you get the surface area of our cuboid, right? Which is nothing but we have two faces of 20 centimeters squared. So 2 times 20. We have two faces of 30 centimeters squared. So 2 times 30. And they also have two faces of 24 centimeters squared. So that's 2 times 24. If I add them all, we end up getting 148 centimeters squared. That's the surface area of this particular cuboid. Let's generalize it then. So instead of 5 centimeters, 6 centimeters, and 4 centimeters, let's replace them by L, W, and H. L for length, W for width, and H for height. So what if this cuboid has a length of L, width of W, and a height of H? What would be the surface area? Now, as you can see, the front and the left and the right faces will have dimensions W times H. The front and the back faces will have dimensions of L times H. And the top and the bottom faces will have dimensions L times W. So we have two faces of area LH, two faces having area W times H, and two faces having area L times W, which means surface area of a cuboid is given by the formula 2 times brackets length times height plus width times height plus length times width. Make a note of that formula. That's how we calculate surface area of any cuboid. Well, now that we have found out surface area for cube and cuboid, let's try and find out how do we find surface area of any prism in general. Okay, for that, let's take this cuboid once again. What are the faces that we have? We have two bases, the one on top and one at the bottom. And then we have four walls in this case. Okay, we'll unwrap the wall one by one. As you can see, there are four walls. And as you know, the surface area is basically all I need to do is add the bases twice, add the areas of the bases twice, right? We need to add the area of these two bases 2 times. And we need to find the area of all the walls put together. Now, if I were to look at it, okay, if I join all the walls of the cuboid or any prism for that matter, it will be a huge rectangle. What is the width of this rectangle? The width of the rectangle will be the same as the height of the prism, as you can see, right? The width of the rectangle is the height of the prism. What do you think is the length of this rectangle? Because remember, we have opened up all the walls to make up for this huge rectangle. The length of this rectangle will actually be the perimeter of the base of the prism, as you can see. Look, the length of that rectangle is the perimeter of the base of the prism, which means to find the area of all the walls, we need to multiply the height of the prism by the perimeter of the base, which means the surface area of the prism will finally be given by 2 times the area of the base, because there are two bases, one on top and one at the bottom. So twice area of the base plus the area of the walls, which is given by the height of the prism times the perimeter of the base. Right? So let's use this formula by giving some dimensions to the original cuboid. So let's say the cuboid had a length of 6, width of 4, and height of 5 centimeters. Let's try and use this formula. First, find the area of the base. Area of the base. Base has length of 6, width of 4. So the area of the base would be 24 centimeters squared, 6 times 4. We multiply it by 2 because there are two bases. So the area of the base would be 2 times 24. Right. Now let's calculate the area of the walls. Remember, how did we find area of the walls? We had height of the prism times the perimeter of the base of the prism. The perimeter of the base, as you can see, is 6 plus 4 plus 6 plus 4, right? Which is 20 centimeters, because the base is a rectangle with dimensions 6 centimeters and 4 centimeters. So the perimeter would be 6 plus 4 plus 6 plus 4, which is 20 centimeters. You multiply it by the height of the prism, which is 5 centimeters. What's 20 times 5? It is 100. And 2 times 24 is 48. So your final answer would be 148 centimeters squared. Right? So remember this formula. That's a general formula for finding surface area of any prism. 2 times the area of the base plus the perimeter of the base multiplied by the height of the prism. Right. Let's look at one more example. Here's one more prism. Let's try and find out the surface area of that prism. Okay. As you know, the base of the prism is the triangular cross section, and the height of the prism is the dimension which is along the length. Okay. In this case, it is a 12 centimeters dimension. With that background, let's put the formula for surface area of the prism. Surface area of the prism, as you know, is 2 times the area of the base plus the perimeter of the base times the height of the prism. Now, what is area of the base? In this case, the base is a triangle having a base side of 4 centimeters and the height of 6 centimeters. And the area of a triangle, as you know, is base times height divided by 2. In this case, it will be 6 times 4 divided by 2, which is 12 centimeters squared. So that's area of the base. We need to multiply it by 2 because surface area requires twice area of the base. So 2 times 12. Then we calculate the area of the walls. For that, we need to calculate the perimeter of the base. In this case, the perimeter of the base is 7 plus 7 plus 4. Now you may wonder, how did I get the 7 on the right? Well, it's not given on the base in the front, but if you look at the base at the behind, at the rear side of the prism, if you look at it on the right side, the dimension is given to us, which is 7 centimeters. Perfect. So the perimeter of the prism would be 7 plus 7 plus 4, which is nothing but 18 centimeters. And the height of the prism, okay, what's the height of the prism? Okay, it's defined there on the prism itself. The height of the prism is the dimension 12 centimeters, right? So we have all the values to calculate the surface area of this prism. Let's go ahead and calculate the surface area then. So 2 times 12 is 24 centimeters squared, and 18 times 12 is 216 centimeters squared, which means the surface area of this prism would be 24 plus 216, which is 240 centimeters squared. Right? Okay, let's take one final example. This is a trapezium based prism. Let's try and calculate the surface area of that prism. First, let's identify the base. The base of this prism is the trapezium, and the height of the prism is the 20 centimeters dimension. And as you know, the surface area of the prism is given by 2 times the area of the base plus the perimeter of the base plus the height of the prism. Okay, area of the base, it's the area of the trapezium, correct? That's the base, and the height is the 20 centimeters dimension. So let's first find the area of the base. How do we calculate the area of any trapezium? It's the sum of the parallel sides, in this case it's 7 and 13, multiplied by the height of the trapezium, which is the distance between the parallel side, in this case 4 meters, and you divide that by 2. Right? Sum of the parallel sides multiplied by the height divided by 2. So the area of the trapezium will be 7 plus 13, which is 20 meters, times 4 divided by 2, which is 40 meters squared. And because in surface area we require twice the area of the base, we'll multiply 40 by 2. So 2 times 40 meters squared. That's area of the two bases. Let's now calculate the perimeter of the base. As you can see in trapezium, we know all the 4 sides. So the perimeter of the base would be 7 plus 5 plus 13 plus 5, which is 30 meters. right? That's the perimeter of the base. And finally, we need the height of the prism. If you look at the original prism, we have identified the height as the dimension having 20 meters as length. So you multiply 20 meters to the 30 meters, which is the perimeter of the base. There you go. We have all the values to find the surface area now. How much is 2 times 40? It is 80 meters squared. And how much is 30 times 20, which is 600 meters squared? So the surface area of this prism would be 80 plus 600, which is 680 meters squared. Well, here's your assignment for this lesson. You need to find the surface area of each of these shapes. We have easier ones in the beginning. We have cubes and cuboids. And then at the bottom, in question number 3, we have triangle-based prisms. And finally, as a challenge, we have prisms having dimensions where one of the dimensions is missing, but surface area is given. Now that's a real challenge, right? You need to go reverse. Try these questions. You may pause the video at this moment if you want. That's the end of the lesson, surface area of prism. I hope you understood the concept which we taught in this lesson. 3 things which we learned. 1, we understood the concept of surface area of any 3D shape. 2, we understood how to find the surface area of cubes and cuboids. And finally, we understood how to find surface area of any prism in general. I enjoyed bringing this session to you. I hope you understood the session as well. Thank you.